This video is going to help explain material on the normal distribution, and it's going to supplement the material that's in the online text. A standard normal variable has a mean, mu, of 0 and a standard deviation of 1. The standard normal variable has a mean of 0 and a standard deviation of 1. It's a continuous variable. It's a symmetric variable. And here I attach to the email the standard normal variable tables, which you have here. As you can see, this is a standard normal variable. The mean right here in the middle is 0. You can see it's symmetric. The area in this piece is 0.5. The area of this piece is 0.5. And if we wanted to find the area between 0 and some number z, say 0 and 0.4, well, the answer is 0.1554. With 1554. If I wanted the area between 0 and 0.42, I would look up 0.4, and then here's a 2, under column 2, and the area between 0 and 0.42 is this number right here. .1628. Again, this is the normal table for a mean of 0 and a standard deviation of 1, but suppose we don't have that. What do we do in that case? Well, let's see. Let's go back to our problem. There is not a problem because we can always make a z transformation. We can transform any x into a normal variable by making the transformation z equal x minus mu over sigma. Let's give an example. Suppose the heights of people in a certain group have a mean of 65 inches and a standard deviation of 5 inches. 65 inches is 5'5", and standard deviation is 5 inches. And suppose I wanted to know what is the probability that someone is exactly 68 inches or 5'8". Well, since it's a continuous distribution, that probability is 0. Nobody is exactly 68 inches. Some people are 68.01, and some people are 68.0003, whatever. In a continuous distribution, there is no probability for any particular point. But we could answer the question, what is the probability that someone has a height between, say, 67 and 68 inches? That's our question. What is the probability someone is between 5'7" and 5'8"? Well, what we first have to do is we have to calculate the transformation using the formula z equal x minus mu over sigma. So the first z is 67 minus 65 over 5, which is 2 over 5, which is 0.4. The second z2 is 68 minus 65 over 5, which is 3 over 5, which is 0.6. And we want to find the area between 67 and 68. The way we're going to do that is we're going to calculate the area less than 68, the probability that someone is shorter than 68 inches. And from that, we're going to subtract the area, the probability that someone is less than 67 inches, and that's going to leave us with whatever is in the middle. So here we have probability z is less than z1, which is the probability that x is less than 67, which is the probability z is less than 0.04, and that's 0.6554. Now, how did I get that 0.6554? Well, from the table that I sent you. Let's go to this table. We want probability z is less than 0.4 is 6.5. There it is, 6.554. That's the number. Okay. 0.67. We'll call that in also. And to get the area, somewhere between 67 and 68 inches, is we just subtract those two numbers. So let's go back to our problem here. So, probability that z is between less than 0.4 is 0.6554. Probability z is less than z2 or less than 68 inches is 0.7257. And when we subtract the two, we get our answer. Probability that x is between 67 and 68 is the probability z is between 0.4 and 0.6, and that is 0.0703. If you like, you could also use the first table. This is the probability that z is between 0 and 0.6. This is the probability that z is between 0 and 0.4. And again, we subtract the two, we get the same answer. Let's give another example. Let me show you a video of this. Yeah. Here's a picture. And you can see here is the mean. Of 65. I hope you can see this. And that is the strip, the area between 67 and 68. Here is a picture of the area between 67 and 68 inches. As you can see, I apologize, it's not that clear. Maybe when you blow it up, you'll see this is the normal distribution. The mean is 65, the standard deviation is 5, and we want the area between 67 and 68 inches. And if you look at that, the area is going to be 0.070325 at the end. Okay, now let's give another example. And here is another example. Just bigger. Suppose, and this is true, IQs are normally distributed with a mean of 100 and a standard deviation of 15. Suppose I want to find out what's the probability that, well, what's the proportion of people whose IQ is greater than 110. So once again, we have to use our transformation. Z is equal to x minus mu over sigma. 110 minus 100 over 15, which is 10 over 15, which is 0.67. So the probability that x is greater than 110 is also equal to the probability that z is greater than 0.67, which is 1 minus the probability that z is less than 0.67, which is 0.7486, and this is 0.2514. Let me show you that 0.7486. Here is my normal table. And cumulative z-chart, we're looking for, here it is right there, probability that z is less than 0.67, and that comes out to 0.7486, as you can see. That's 0.67, and 1 minus that would be the area to the higher than that, which would be the answer that we just got. So let's go back here. And I'm going to be sending you this whole Word document so you can follow it along. Let's ask now another question. Suppose I want to know, or you want to have a club. But in order to get into the club, you have to have the top 10% in IQs. Or you have to have 90% of the people lower than you. So, how do we find what is the IQ that is necessary in order to be in the top 10% or 90% less than you? So, the way we do that is we look up in our Z table. And here's the standard Z table. And I'm looking for 90%. And 90% corresponds to, well, there's no 90% exactly, but the 90%, that 90% is 0.8997. That's closest to 90%. We also have 9015, and we also have 9. This one is the closest to 90%. And that corresponds to 1.2, as you can see, and then here is an 8 on the top of the page. There's the 8. So that comes out to 1.28, and now let's go back to our document. So z is 1.28, and 1.28 is equal to x minus 100 over 15, and that comes out to be 119.2. 119.2. So, in order to get into this club, if you have an IQ of 119.2 or better, you can brag that you are smarter than 90% of the people, and you are admitted to this club, high IQs. What I'd like to do now is I'd like to show you how to use the online stat book a little bit more carefully. And here we have let's go back to the online statistics book. And this is the screen that you see when you type in the page online statistics book. Trying to get it clearer. Let's type onlinestatbook.com. And then you click on version 2. See that? That's in big letters. And then you click on normal distributions. And then here you have a whole bunch of information and areas of normal distributions. Click on this. And here you could read what it has to say about normal distributions. One of the things that it says is 68% are within one standard deviation of the mean. So, for example, if the mean of a population is 50 and the standard deviation is 10, then 68% is going to be between 40 and 60. You could read all of this, and you could listen to the video if you like by clicking that key up here. We'll show you that in a minute. And here we have another example, and here we have 95% are between 1.96 standard deviations of the mean. Okay, and you could read that. And if you want to click on this applet, click over there and allow it to run. And then you can put in any number you want here. For example, the number that I did over the last time, the mean was 65. Well, let's do that other one. The mean was 100. And the standard deviation is 15. And I want to find out what IQ, what is the probability that someone has an IQ less than 110. And then the area is, as you can see, 0.7457. Hopefully you can see that. It's not so clear. Okay. Well, anyway, if you run it, you'll see it. Now, the last question, we could do this applet. Calculate x for a given area. Click on this applet, and now you click Run. And then you want to find the mean is 100. The standard deviation is 15. And we want to know the top 10%, or 0.90. Put a 0.90 in that box. And then this is 119.223. It's the same number we had before. I don't think how clear it is. Maybe when you blow it up, it'll be a little bit clearer. Okay, and then what I would like you to do is I'd like you to answer these questions. Now, at the end of the chapter, they have 6 questions. Here's the first question. We'll do that together. A distribution has a mean of 40 and a standard deviation of 5. 68% of the distribution can be found between what two numbers? Well, 68% is between 40 minus 1 standard deviation and 40 plus 1 standard deviation. So the answer should be between 35 and 45. If you click this 35 and 45 and then you ask it to check your answer, you get a big smiley face, and it'll tell you that you got the right answer. If you pick a wrong answer, like this one, it'll tell you why it's the wrong answer, and you can try and figure it out better. And then you go to the next question, and so on and so forth. Try answering those 6 questions, and we will continue with the normal distribution and confidence intervals on April the 8th. I'm also attaching the Word document that has all that information on it, with the means and standard deviations, all the different problems. And I'm also attaching the tables and the video. The video is going to be as a YouTube. Okay, see you on the 8th, and have a happy holiday. Bye-bye.